Hi everybody, it's Mrs. Cassell, and you can probably tell from the glow of my face, then I guess the clock behind me, that it is late and I am at home. We have sick people in our house, so we are working very hard to keep that sickness from spreading, and it means that I can't be there with you today. So here's what you're going to do. Before winter break, we were working on our air hockey lab, our low friction glider lab. And we didn't quite make it all the way to the end, not because you guys didn't do an awesome job, but because to get to the depth that we needed in order for you to understand what your data meant, how you could use it to construct an argument, that all required more time. So this is an alternative form of the same lab. I've used this version in the past when I've had students who were absent or when a new student transfers in and they missed the lab. But the reality is, it'll allow you to collect the same data and theoretically construct the same argument of the same quality and depth that we were going for with your first lab. So, the rubric. If you look at the bottom of this page, you'll see the rubric. It is, will it let me, does it only show it when teachers are doing it? Here, let me move my base for a second. This is what happens when I start talking. Oh, it does show. Okay. So this will be, I haven't published it yet, that's why. So, but here's the rubric, you can see it. This is very thorough, you'll notice, and this is straight from the AP handbook, because that air hockey lab, that was our janky version of how to do it, but it's actually one of the official AP Physics 1 labs, taking this modified Atwood machine and figuring out how you can show that Newton's law does in fact work the way I told you it did based on the data and the patterns that you can observe. So these are some of the science practices that are part of the AP standards. They're pretty deep. Represent, models, phenomena. So you have a simulated model. Can you use it correctly to get data that's meaningful? Student can justify the selection of the kind of data needed. For this, I've provided you with a data table. So it gives you a procedure and some prompts to help you get started. So you should be able to do this. You should be able to follow those directions and complete this. The student can design a plan for collecting data. Okay, so I've done that for you in this simulated version, and you all did it before break, and I got to see that you had plans that were going to make sense. The student can collect data to answer a particular scientific question. So like I said, I've set things up for you, but can you actually complete that process? Do you know when to throw out your data? Do you know when you've created enough variety? Do you know when you look at a graph if you've got enough data points for it to be meaningful? Do you need to add more data than what I've provided space for? Make a smart data-related decision. The student can analyze data to identify patterns or relationships. This is the big one, right? This is the heart of where this lab lives, which is cool. So you've got some data. Who cares? How have other scientists looked at raw sets of data like that, found patterns, analyzed it, tested it, found out what kind of pattern it is, and then said, hey, guess what? This describes a rule. That's really where you were at in this lab. Student can evaluate evidence provided. So I've given you some instructions for what kinds of graphs to make, but not what they mean. This is also part of your job here. How can you take those patterns that come from a graph and use them to get to your question, which is the mathematical relationship represented by Newton's second law? And then lastly, can you complete this whole thing? It was a weird number of points, you guys know. I'm like, I just wanted it to be a number ending at 0. So, congratulations, 6 free points. So that's the rubric for what this looks like. Your lab document has you use the same simulation that we've used sort of as our pre-lab beforehand. You'll notice I've set up a data table for you. Please read the procedure. This is the most critical skill in doing almost all learning is can you read directions and follow through with them. So set up a data table for you. I don't know how many data points this is. If you need more, if you decide you need less, then let's hear this count. 1, 2, 3, 4, 5. It's like 9 data points. How awkward. Okay. Part 2, you're going to use the same simulation, but just like your air hockey lab, I'm suggesting you vary the glider mass. So this should all look familiar because we sort of did this in our pre-lab. But then we're going to do this analysis, okay? You're going to make 3 different graphs. There's a spreadsheet template to make it for you. This is fake data. Don't use this data. I literally just typed things in there to show you some sort of things. Okay, so it's not real. Don't use it. So you're going to put your data into this spreadsheet. You'll see right here, part 1, there's a spreadsheet area for the glider mass and the acceleration that you calculate. And then you'll see I've created the graph for you. Learning how to make a spreadsheet, obey your commands, and create a graph used to be a lot easier because computers weren't as smart as they are now. Now, even simple programs like Google Sheets tried to be smarter than a lot of users, which can make it really frustrating when it incorrectly anticipates what you're trying to do. So, I'd be happy to teach you how to use this later. Obviously, I know how to do this, and this is dead useful in science and engineering. But in the meantime, I set this up for you so that you can enter your data, and as long as you don't muck around too much, this graph will change to reflect what data you've entered. For part 2, you'll see there were 2 steps requested in your lab instructions. Graph acceleration versus glider mass. And then do it again, but this time do acceleration versus 1 divided by the glider mass. Okay. So you'll get 2 graphs. One that should be a curve, which is difficult to analyze, and one that is now linear. That means a y equals mx plus b graph. You know how to do those kind of graphs. You know how to look at a line, find points on it, and calculate things. This is where you're getting into things. You've got 2 graphs with straight lines. This is going to help you analyze your data and find an actual pattern. Please put your 3 graphs into the lab document. Doesn't matter how big they are. You can make the thing scroll onto more pages if you want. And then your job is to write an argument. Right? This is not just a 1, 2, 3 sentence conclusion. Okay, you're not an 8th grader anymore. This is an argument. Imagine that you were trying to win a legal case. If your lawyer stood up and said, "My client is innocent. I know this because on the day of the crime, they were somewhere else. Therefore, they couldn't have possibly committed the crime. The defense rests." You'd be in trouble, right? Your claim is a thorough explanation addressing the question. It's clear, it's explicit, it uses the terminology in the question, and it makes sense. This is the bold answer to the question. It might be more than 1 sentence. Should it be a whole paragraph? Probably not, but several sentences might be necessary. Your evidence. This is not where you just repeat your data table. I can read your data table. It's in this document. I'm going to read it, okay? But instead, you need to explain the pattern and relationships you find. You need to not just explain them, you need to describe them because they are the result of you analyzing the raw data. You did a bunch of science, then you did something with those numbers. Your evidence came from that. There's more than one kind of data that you could put here. So your graphs are a critical piece of this. But a lot of you also will be able to think about your problem a little differently. Evidence comes in all sorts of different forms. I'd lean heavily on your graphs, but if you've got a logical part of your brain that says, I have something I want to say here that I think is good evidence that supports my claim, add it. Okay, the last part that's here, your justification. And you'll see it says why your group thinks your evidence matters. That's because we originally did this lab as a team, right? Take this to heart. You guys, I'm not there. Feel free to talk to each other and help each other, okay? Becoming a scientist is a team effort. I don't know anyone in science who succeeded alone. I mean, they're depicted that way in movies and TV shows, but so are teachers and airplane pilots and astronauts and athletes and ballet dancers and superheroes, right? So, most of us, the vast majority of humanity, succeeds in a group. So, talk with one another, help each other out. But your justification, this is the hardest part to explain, but why should I believe you? Why is your evidence good? And remember, in this case, your evidence isn't just the numbers that you measured with a stopwatch in the simulation. You did a bunch of math. You did some graphing. Can you justify why that was good work that you did there? Why that is evidence instead of just your raw numbers? How did your methods, how did the things that you did provide accuracy to make your measurements valid? Okay, well, we'll be clear about one thing here. You are using a simulation, so it's going to be really valid because it's not a real air hockey table. But this is about the why. Why does your evidence connect to your claim? When I was a student, we called it the warrant. You can give somebody a bunch of facts. We live in a day and age where this happens, and people just go, whatever, I don't accept your claim, I don't accept your evidence. Justification is the thing that ties those two together. This is the why, and this is a lot harder for a skeptic to deny or argue against because they need their own evidence to unravel your justification. So why should I believe you? Why is your evidence good? Why is your explanation of it solid? Why was it the right evidence to include to support your claim? Right? This was a long video, but I'm not there to walk you through this, so watch it in bits and pieces, fast forward, mute me if necessary, right? So to sort of wrap up, your goal today, Monday, man, you think I would have like fixed my hair before I did this too? Okay, yeah. Life in the time of COVID is just the worst. So, so today, your first goal should be conducting the simulation, collecting your data, getting your graphs started. Some of you might blitz your way through that, which is great. The second day of this, I want you to really work on your writing. If this was a 5-paragraph essay, you wouldn't be done with it in 10 minutes, like many conclusions in science are written. That's really how in-depth this analysis is. Think back to the language in that rubric. It's for reals. I'm going to be looking for those things in your writing in here. And granted, a single sentence might address more than one of those science practices that were listed on that rubric. It's absolutely true. But still, your second day should be really refining this writing. Okay? Thanks, everybody. I miss you. Be safe, make good choices, and I'll see you soon.